Hello YouTube, my name is Saiha. I am finally able to put up a new video for Project Leonhartz. I'm sorry for taking for quite a while, but finally I'm back. Let me give you a little update on what I've been doing with the project so far in the past year. I was still working with the project on and off the whole time. I was looking into randomly generated terrain, voxel terrain generation, inventory system, and also mostly combat system. I've been working on combat system for a long time. I think about 4 or 5 months. I've experimented with so many different implementation, and most of them fail. But I finally got a good structure that I think could fit into my game. But yeah, I've been working with all these things, and I've been experimenting with a lot of different implementation for each of them. And yeah, because most of them fail and I have a lot of glitches and stuff that I couldn't fix them all, and everything is just quite messy. That's why I couldn't make a proper video to upload. So yeah, that's what I've been doing so far. And now after I've gone through a lot of them, and then I found a problem with my implementation with the position syncing, the movement synchronization, and so I decided to come back and redo that. And after I finished that, I find that I kind of have a good implementation right now, so I thought I can just make a video and show you guys how I do it. So yeah, let's continue with the from where we left off, and look into how we can synchronize the position from the client to the server and back to the proxies. Okay, so first I'm going to talk about the uLink's implementation, and here we're back at Paint again, my favorite graphic design software. So how does uLink, the sample script that was given by uLink, implement the synchronization? First, if you look at the Snowbox sample project, you will see that inside the prefab of the character, you will see one of the script called uLink platform controller, I think, but I'm not using it here. I have my own implementation, but that one I think is called uLink. It's inside here, plugin uLink utility script. Here it's uLink strict platformer. That's what they use for the synchronization. This one it also handle jumping and jumping, yeah, because that's why it's called platformer, because it has jumping. And the other one is a simpler implementation, which is called strict character here. This one it just take the position and then just synchronize it with the server. But for this one, it has smoother jumping because the server also calculate the jumping. It has a physics calculation inside the server, so that it's much smoother and more accurate for jumping. But for this one, it simply synchronize the position, but it doesn't care whether you're jumping, you're falling, or whatever. It doesn't care at all. So this one is just a little more complicated, but you can check on them. To be honest, I don't really like their implementation here. I think it's very messy. In the strict platformer, they need a whole bunch of script. They have like 2 more scripts that have to do with the controller, like how to move the character on the client, and then it link back into the strict platformer here, and then it link back and forth in a really messy way. I really don't like them. strict character here is a little simpler, so I think it's easier to understand if you read them. Anyway, I will not go into those scripts and then explain everything in them, because I think it's very confusing. So I'm just going to summarize their concept, and here we go. So what they do is, every frame after you update your character movement using your character controller script, the strict platformer will send the data, send your positioning data to the server, and the data that they send is this. They send velocity and the new position. And also there are the time data as well, network time, but it is inside the overhead of the RPC, so you don't need to specify it. The server always know when the data was sent from the client. So that's what they send to the server, and what the server do with this data is that first it calculates the delta time. The delta times just mean the difference between the last frame and this frame. And to calculate that, the server just take the time that this message was sent to it previously. So it store that. If this is the first time you send, it doesn't have any previous data. It's just store that data, and it doesn't do anything else because the delta time is 0. So if you send that first, and then the second time you send the data, it will find the delta time because there is a time difference there. So it just take the new time and then subtract with the previous time that was sent, and it get the delta time. And after that, it check. Oh, I forgot. It also do a verification in here. Maybe I should put. It also verify the velocity. So they also verify the velocity. So the velocity that's sent by the client here, the server will check whether that velocity is within the maximum limit. That's one basic way to combat against hacking, unfair play. So yeah, you simply check that. Inside the script, I think they will have that. Inside my script, I also have that. Here, as in character creator, that is they call it the square root maximum here server speed, I think. Yeah, that is the maximum velocity that you can go, and it is a square root figure. I mean, not square root, this is all the squared figure. So yeah, we just verify that, and then if the velocity is within the limit, we simply move the character. We use character.move, I think, character controller.move function to move that character toward the new position using the velocity. So the equation is just velocity times delta time here, then you get the new vector 3, and then just plug it into character controller.move. That will move the character, and after that you get a new position. So then you verify the new position against the new position that the client sent you. So yeah, if there is any difference, and you can approve or disapprove based on those data. So you have the tolerance as well. And here we have the max server error, also squared value. So yeah, if this new position on the server compared to the new position on the client is too great compared to that compared to that maximum limit, then you simply send a disapprove message. If it's not, then it's fine, you just send an approve message. And the problem is approving is fine, it's easy, no problem, but for disapprove there is it's a little more complicated. So how do you disapprove? So disapprove, it just it means this data is wrong, and you have to send the position on the server side back to the client side. So you need to use another RPC call back to the client and then send the new position there. And there is a little more complication here because of the ping. We have latency. So by the time that the server decides that this position is wrong and send a correction back to the server, back to the client has already moved many frames already. Let's say we have a client that is running at 50 frames per second, which is 20 millisecond per frame, and we have a network which is 120 ping latency. So that means it takes 60 milliseconds to go to the server and another 60 milliseconds back to the client. That 120 milliseconds, that's already 6 frames inside the client side. So you have 1, 2, 3, 4, 5, 6. So the client has already moved 6 more steps before the server say that, okay, this one here is wrong. So what do we do when that happens? So this is why you have to store the movement on the client. You have to store them in a list of what action you have taken until you get the message back from the server that the action was approved. So let's say we stored these seven frames so far, and then this new message was sent from the server that this action here was not approved, was wrong. So what we do is just turn the player, put the position of the player back to what the server has sent, the new position that the server sent. So we just transport that back to that position and then redo all of these action again. Yeah, that's how you do disapproval. So that means you have to store this data, the velocity and the delta time, inside the client, inside an array list. Yeah, that's it. So that is the implementation for that was used by uLink inside the script, the uLink's strict platformer and the uLink's strict character. Yeah. I'm going to cut the video here because I don't want it to be too long. My computer is very slow, so the render time is horrendous. Anyway, so that's how uLink implement their synchronization. And in the next part, I will talk about my own implementation and also some problem that I have with uLink's implementation and why I decided to write my own script. Anyway, thank you very much for watching, and I will see you in the next video.